Okay, this video is on applications of integration, area, and volume between curves. So the first question reads, the two functions are graphed above. The red function is represented by f of x equals 4x squared minus 6x plus 3, and the blue function is represented by g of x equals cosine of 3x squared plus 3. The two functions' point of intersections are labeled as above. So these are the points of inflections, right? Okay. And then it says find area between the two curves with respect to x. Okay, so integrals are used to find the area between two curves. So first we need to identify which one is the above function. So we can see that the red function is above all the y values of the blue functions within this interval, right? The interval of intersection. So to find the area, we're just going to do area equals, the intersection points are going to be 0.764 since we're taking this with respect to x, and then 1.275, and then we're gonna do the above function, which is 4x squared. Okay, let's just write 4x f of x minus g of x dx, which is equal to and then alright, so this is how you get the area. We're gonna try to take the integral on our calculators. So 0.764 and 1.275, and then 4x to the second power minus 6x plus 3, 6x plus 3, and minus cosine of 3x to the second power plus 3. Okay, I think that's it. And then we're gonna get the answer. And we got the answer of 0.252. We're gonna do 3 decimal places for BC. So that's our area. Okay, so for part B, it says find the volume of the solid that would form if the area bounded by the two curves is revolved around the line y equals 1. So because this is pretty complicated, I drew a graph for you. So we have the line y equals 1 right here, right? We have y equals 1 right here, right? And then when this shape is revolved around y equals 1, it would have a little bit of a gap in here, right? The gap I can just color in using this color. This is like the gap, right? This is the gap, and then you revolve this area, right? You revolve this area, so an identical shaped but I guess like reflected version of this would be this one, right? This would form, and then there would also be like a giant, I guess oval shaped or circular shaped base of the area. So that would be the base, I guess. Okay, so this would be it. And then because there is like a gap between here, the red function, and the y equals 1, that's why this orangish red color gap is formed. So this is basically the general shape. Just doing it again, this would be like this shape. Technically it'll be like this, and then this area is not filled inside. So we can see that we have to use washer methods since we have something in between that's not filled. Alright, so okay, and then to help you with like forming your integral equation, we have y equals, which is like f of x, 4x squared minus 6x plus 3, right? We also have y equals cosine 3x squared plus 3, right? And then our line that's being revolved around is going to be y equals 1, right? We can see that everything is in terms of y. And then because all the functions are in the same term, or like, yeah, written in the same term as the line that's being revolved around, that means that we don't have to use cylindrical shells, and then we can put everything with respect to x in our equation. So that's what we're gonna do. Yeah. Okay. And then, so first v equals, since we're using washer method, we're gonna put a little pi out here. And then because I said we're doing everything with respect to x, we're going to see where we're going to see the, like, I guess the x ends of the area. So again, that's 0.764 and then 1.275. 0.764, 1.275. Okay, and then everything's in terms of x, right? And then we have this line right here, which is y equals 1 again. And then we also have, so we're trying to find the outside function in this case. So the outside function obviously is going to be the blue one, right? This is the outside. Like, you travel around this much and then you subtract like this much. That's between y equals 1 and the red function, okay? So this is the outside function. So outside function would be 1 minus, and then whatever this blue line is, right? So blue line is cosine 3x squared plus 3, right? So we're going to square this whole thing. Yeah, this is our newly found function, okay? 1 minus cosine of 3x squared plus 3, this whole thing squared, and then minus the inside function, which would be this much, right? So it will be 1 minus the red function, which is 4x squared minus 6x plus 3 to the power of 2, right? This is going to be the radius, I guess. This is also radius. This is radius 2, this is radius 1, okay? 1 minus minus 6x, okay. Alright, so this whole thing squared, and then dx. Alright, so this is the equation, so make sure that you're plugging it into the calculator. I won't be plugging it in right now because it takes some time. Okay, and then it says find the volume of the solid that would form if the area bounded by two curves is revolved around the y-axis. So y-axis is right here, right? This is the y-axis. So y-axis is when x equals to 0, right? So it's essentially we're revolving around the line x equals 0. So in this case, the functions are all written in terms of x, right? But then the line is actually x equals 0. So we're revolving around x equals 0, which is not in the terms that is the same as all of the functions that we have. So that means that we need to use cylindrical shells. Sometimes you can rewrite your functions to match the term of the line being revolved because you can't really change which line is being revolved, right? So, but then in this case, there is no way to really rewrite the functions so that they would match x equals form. So we're just going to use cylindrical shells. So cylindrical shells, v equals 2 pi times, and then we're still going to use the intervals in x because our functions are in x. So 0.764 and then 1.275. So whenever you're trying to find the limits of integration, just look at what your functions are like in terms of, even if it's cylindrical shells method. Okay, and then now we are trying to find, okay, so we're doing this, right? So I think generally we're trying to find a shape like this. It's like that, and then here's like a huge gap between like these two functions. Yeah, about this. And because we are putting this in terms of x, and then we're revolving this around x equals 0, right? So to find our radius, it's going to be like this part, because just remember, like, just memorize this. If it's in terms of x, then the x will be in like the horizontal, or like the radius will be like horizontal, and then if it's in terms of y, it would be in vertical direction along like the x-axis and along the y-axis. Okay, so this would be our radius, and then we're trying to find the height, right? The height of the shape, and then the height would be perpendicular to radius, so the height would be this part right here. So that means that we're trying to subtract the red, or subtract the blue from the red. Okay, so our function would be just x, right? Because this is the x, this is the y-axis, so it's not a non-axis following revolution, so there's nothing that we're subtracting from x. And then our height, which would be 4x squared 6x plus 3 minus cosine 3x squared plus 3. Okay, so this would be our integral function. Since we're giving you the equation for the integral, you can just plug this into your calculator and find the answer. Thank you.